Okay, so now we're going to take a look at nested loops. So similar to if statements, our loops can also be nested within each other. So the specific one that I'm going to be taking a look at here is going to be dealing with for loops. In most cases, you will deal with nested for loops. To determine the total number of iterations of the innermost loop, so in this particular example, the innermost loop is going to be the one related to seconds. You are going to multiply the number of iterations of each loop together. So before I get into this particular example where we're dealing with hours, minutes, and seconds, I want to try to present this with a slightly shorter, kind of smaller example to really kind of clarify precisely why it is that the number of iterations of the innermost loop is going to be the product of all the loops. So I'm going to go ahead and minimize this for a moment. I'll go ahead and take a look at a shorter example. Go ahead and create a new project. We're going to make a new Java application. We're going to go ahead and call this one nested loops. So go ahead and create that. Click finish. Go ahead and remove the extra comments. And adjust the style of this a little bit. And then inside of the main method right here, what I will go ahead and do is create two for loops. So I'll have one inside of another. So for the outer for loop, I'm going to do for int I equal to, let's say, let's continue to do 1. I'll say as long as I is less than or equal to 3. And we'll do I++. So this first part right here, this is going to be my outer for loop. And then inside of this, I'm going to go ahead and create another for loop. And so because I used I for the outer for loop, pretty standard approach for this. Whenever you see a lot of theoretical examples of nested loops, they're going to do I for the outer loop, and then they're going to do J for the inner loop. So they'll just do, essentially just going alphabetically. So say int J, we can make this one equal to 1 as well. And we'll say as long as J is less than or equal to 3, and then we'll do J++. And then inside of here, what I'm going to go ahead and do is just print out two things. So we're going to do a print statement. And inside of here, what I'm going to go ahead and print out is just going to be the two different values that I'm currently looking at. So that's going to be I plus, and then I'll have a space. So I'm going to use a string literal for the space, and then J. So we're going to print out the value of I. It's going to be essentially a left column, and then J for a right column. And so the way this is going to work is I will come to this outer for loop. I'm going to see my int I equal to 1. I is less than or equal to 3. 1 is less than or equal to 3. That's true. So we'll then come into here. So then we're going to be taking a look at everything that's in the body of that outer for loop, which is basically this entire inner for loop. So then we're going to take a look at this. We'll see that int J equal to 1. So we're going to go ahead and declare this. So we now have a variable called J, initialize it to 1. Again, we're going to say J less than or equal to 3. That'll still be true since J is also 1. So then, because that's true, we'll go ahead and execute line 11, so the body of that inner for loop. So the very first time that we run this, I is equal to 1 and J is equal to 1. So we're going to do 1, and then a space, and then a 1. And the reason that we're able to see both of these variables is because of the fact that since this entire for loop is within the scope of the outer for loop, that means that we do have access to I within the entire scope of this. One of the things that we would have to keep in mind, though, is that once we leave this inner for loop, so we come to this line right here, so this is in the body of the outer for loop, but not the inner for loop. So one thing we would have to keep in mind is that J would no longer be accessible here. Only I would be. Anyways, so we'll go ahead and do the first print statement, then we'll come over here, and for this one, we're only going to increment the value of J, so only J is changing with each iteration of this for loop, but I stays the same. So I is still going to be 1, but J is going to be incremented to 2, so we would then go ahead and say 2 less than or equal to 3, that's still true. We'll go ahead and print out this statement here, so we're now going to see 1 and then 2. We'll then go ahead and repeat this. So we'll do another increment on J, so it becomes 3. 3 is still less than or equal to 3, so then we'll go ahead and print out the statement right here, 1 and 3. Again, our I still hasn't changed. Then we'll go ahead and increment j once more. So j will become 4. That is going to be false. 4 is not less than or equal to 3. So that means that we're done with this inner for loop, but we're only done with this inner for loop for the first iteration of the outer for loop, because we're going to reach the bottom right here, which is the end of the body of our outer for loop. So then we're going to come back to the beginning of that outer for loop. So we're going to come up here to I++, we're going to increment that. So now I is going to have the value 2. We'll see that 2 less than or equal to 3, that's true. So now we're going to repeat everything that we just did, but now the value of I for all of this is going to be 2. So now we're going to see 2 and 1. We're going to go ahead and redeclare this int variable j. So we'll go ahead and essentially remake it. Again, we're going to initialize it to 1. So now we're going to see the values 2, 1 print out here, and then 2, 2, and then 2, 3. Then we're going to reach the end of our inner for loop, and we're going to repeat the outer for loop again. So for that one, we're going to see when we get to this print statement, we're going to have 3, 1, 3, 2, and then 3, 3. And then when we hit 3, 3, that's the end of the inner for loop. And then when we come over to our outer for loop, we'll increment I to 4. We'll see that this is false. So this is also going to be the end of our outer for loop. So you can see that for each iteration of the outer for loop, we have to go through all of the iterations of the inner for loop. And so because of the fact that the inner for loop is going to iterate 3 times, we've got 1, 2, and 3, and the outer loop is going to iterate 3 times, 1, 2, and 3. Essentially, to get the total number of iterations, in this case, the total number of times that we're going to print something to the console, it's just going to be the 3 iterations here multiplied by the 3 iterations here, because we had 3 for the first one, another 3 for the next one, and then another 3 for the last one. So 3, 6, 9. So if we go ahead and run this, we can see each one of those different pairs that I mentioned print out to the console. So for the very first one, we're going to have 1, 1, and then 1, 2, and then 1, 3. So that's for all 3 times when I is equal to 1. We then have 2, 1, 2, 2, and 2, 3. That's going to be for when I is equal to 2. And then 3, 1, 3, 2, and 3, 3. That's going to be for when I is equal to 3. Okay, so now that we've seen that, now we're going to go ahead and modify this to use the example that we just saw with time. So with that example, we're going to be dealing with 3 for loops. So we've got one right here at the very top, which is going to be for hours. The next one inside is going to be for minutes. And then we're going to have a third one for seconds. We're going to kind of put that all together. So right here, we'll go ahead and do for int hours. This will initially be set to 1. And we'll keep going for as long as it is less than or equal to 12. Go ahead and increment this. So change both of these to hours. For the next one, we're going to go ahead and do this with minutes. So when you're dealing with the minutes and seconds, obviously these start from 0 instead. And they'll keep going until they hit 59, because then once they go up past that, it just moves to the next hour. So say something like 12:59 just moves to 1 o'clock. So we're going to do minutes, as long as this is less than or equal to 59. And we'll go ahead and keep incrementing that. And then go ahead and do the same thing for seconds. So we'll go ahead and remove this, replace this with the third for loop. So say for int seconds equal to 0, seconds less than or equal to 59, and then do seconds plus plus. And then right here, this is where we're going to go ahead and put in that print statement. So in this case, I'm going to be doing it with printf because I need to go ahead and format this a certain way. So we're going to go do system.out.printf. So let's go ahead and remove a couple of things here. Okay. So for this particular example, what we're going to do is we want to print out the hours, minutes, and seconds, pretty much as if this were, say, like a digital clock. So we're going to print out the hours. It has 2 spots for it. So we're going to go ahead and do %. And we know that we want to use D as our conversion character for this because of the fact that we're dealing with integers or int variables. The other thing I want to go ahead and specify is going to be the width for it, which is going to be 2. For the rest of these, I'm again going to do %2d, but I also want to go ahead and specify this. Say, for example, if we were doing, say like 1205, we know that we need a 0 and a 5. So because I need those leading zeros, I want to go ahead and include that as one of my flags for these. So I'm going to say %02D for this part. And then we can go ahead and do the same thing for the seconds. So we'll go ahead and do %02D for that as well. And then right here, we'll go ahead and just do our hours, minutes, and seconds. Go ahead and save that. And one thing to double check about the example. Yeah, so we'll go ahead and do leading zeros for the hours as well. That one's primarily just to keep everything exactly aligned. So in this particular case, we're just going to go and do 02D for all of them. So all three of these are going to have a leading 0. They have a width of 2. So we always make sure that we have that leading 0 for values 1 through 9. So if we go ahead and run this, I should go ahead and include a new line character to make this a little bit easier to read. So we're going to do a %n at the very end. Run that again. Okay. So at this point now, it took a little bit of time for it to print out, but essentially we've printed out every time. So if you go back to the very beginning, starting from 1 o'clock and then going all the way through every one of the different seconds and minutes and hours until we get to 12:59:59. So basically it just goes through an entire half of a day, so a whole 12 hours that it steps through. So then, if we wanted to double check exactly how many times this ran, so the total number of these print statements that we have to the console here, what we can go ahead and do is just multiply together the number of iterations of each of these different loops. So the very first one right here, for the hours, it's going to do the numbers 1 through 12, so that gives us 12 different values. For the next one, we're going to do 0 through 59, so because we start at 0, this is going to be 60 different minutes that we go through. And then for seconds, same thing as the minutes, we start from 0, go up to 59, so that's another 60. So we're going to do 12 multiplied by 60 multiplied by 60. So then, once we do all of that, we can see right here, for our outermost loop related to hours, we have 12 iterations. The middle and the innermost loop related to minutes and seconds, those both have 60 iterations. So the total number of iterations after all of these loops have completed execution is 12 times 60 times 60, or 43,200. So put another way, this basically tells us the number of seconds in 12 hours. Okay, so at this point, this is going to wrap up nested loops. In the next video, I'm going to kind of conclude with everything about loops that we've seen, so the while loop, do while loop, and the for loop, by talking just briefly about the different use cases for each, so we kind of understand when it's appropriate to use one loop versus another.